Topic of discussion is surface energy and surface tension. Now see, an extra energy is associated with the surface of the liquid. The creation of more surface, keeping volume fixed, requires some additional energy. Now some additional energy is required to generate a surface, we can say. Now see, this is a U-shaped tube, okay, and there is one wire which is attached to these arms of the U-shaped tube, which can be slide easily without any friction. Okay. Now this frame is dipped in the soap solution. So what will happen if you dip this frame in the soap solution, then there will be a thin film which is produced here in this particular region. Okay. So this ABQP is a small film or a thin film which is produced here when this is dipped in the soap solution. Now in this first figure, this film is in the equilibrium. Now area of the surface increases. Now try to understand, we want to stretch this film. Say for example, this is in equilibrium right now. Now there is a thread. With the help of this thread you are applying some force and you are bringing this wire from this initial position to certain another position. So there is a displacement of this wire by D. So some work has to be done. Okay. The breadth of this is L. Okay. Now, since the area of the surface increases, the system now has more energy, means that some work has to be done against the internal force. Now this work done is nothing but force into displacement. So it is Fd cos theta. Force is in this particular direction, displacement is also in the same direction, you can see. Okay. The force applied is in this direction and displacement is also in this direction. So both are having angle between them as 0. So we can write W is equal to Fd cos 0, that is F into D. From the conservation of energy, this energy will be stored in the additional extra energy in the film. Now if the surface energy of the film is S per unit area, you take the surface energy per unit area initially as S, then extra energy which is stored, now see how much increase in the area is there. Increase in the area is this much, that is length into breadth, so L into D. Now this film has two surfaces, so total increase in the area is 2L into D. So here it is written as increase in the area as 2LD. Okay. The liquid in between, there is a liquid in between the two surfaces, that is why it is multiplied by 2. Now the increase in area is 2LD. Okay. Surface energy per unit area is S. So total now extra energy which is stored is increase in area, that is 2LD multiplied by surface energy per unit area, that is S. So work done is nothing but 2LD into S. Now see, 2L into D is nothing but change in area. So we show it by delta A. So that 2L into D will become delta A and it becomes S into delta A. 2L into D is delta A, that is increase in area. So surface energy per unit area is work done upon change in area, that is delta A. Now as you know, work done is force into displacement. So this becomes 2L into D. Okay. Now this D will be cancelled out. Okay. Delta A is already known to us, it is 2LD. So force upon 2L will be the surface tension or surface energy per unit area, or we can say force per unit length. Both the way it is correct. Force per unit length is also surface tension, and energy per unit area is also called the surface tension. It is equal to the surface energy per unit area of the liquid interface and is also equal to the force per unit area exerted by the fluid on the movable bar. Okay. Now see, when the liquid is in contact with another liquid, say for example in case of the surface of one fluid is in contact with other fluid, or it is in contact with the solid, okay, then surface tension, or we can say surface energy, depends on which factors, okay. In the case of surface of one fluid in contact with other fluid or solid, say for example water is spilled in the glass, say, then what will happen? Water is in contact with the glass, okay. Now if you take the steel glass, if you take a what do you call it, glass, okay, which is different than the steel. So when the liquid, that is water, is in contact with steel, water is in contact with the glass, there are different material, okay. The surface tension depends on the materials on both the side of the surface. If the molecules of the material attract each other, then surface energy is reduced. If the molecules of these materials are having an attractive force between them, then surface energy reduces. If they repel each other, then surface energy is increased. Thus, we can say that the surface energy is the energy of the interface between the two materials and depends on both of them, okay. Now we define the surface tension, okay. This is the figure which is given to us, okay. This is a liquid surface which is shown here in this figure, okay. Now in below figure, a free surface of the liquid is shown. Then there is a line which is drawn here. See, this is a line which is drawn, okay. We are having unit length, okay. Its length is 1 unit in the middle of the surface, except near the wall, okay, except near to the wall is shown. So this line is drawn in the middle of the liquid surface, not here or here, okay. The line is somewhere in the middle, okay. Now the force exerted on both the side of line, force exerted on both the side of line perpendicular to the line. One, the force is exerted in this direction, the other force is in this direction, okay. So the force exerted on both side of line perpendicular to the line and parallel to the surface. This force is parallel to the surface. Then if length of line is L, okay, and force is F, then force per unit length is defined as surface tension, okay. So F upon L is the surface tension, its unit will be Newton per meter, okay. Now you can define it in a different way, okay. The potential energy stored per unit area of the free surface of the liquid. So energy per unit area which is stored in the free surface of the liquid, that is also defined as surface tension. Its unit is joule per meter square. It must be meter square here, okay. Or a third way is the work done to increase the unit surface area of the liquid is equal to the surface tension. So work upon unit surface area is increased, or work done upon the area increased, that is also defined as the surface tension. So there are three different ways by you can define the surface tension. Now, one certain value of surface tension is depending on some parameter. The value of surface tension basically is depending upon the temperature. The critical temperature is the temperature when the surface tension becomes 0. Now, critical temperature of water is 37.4 degree Celsius. Like viscosity, surface tension of liquid decreases with temperature. Surface tension of some of the liquids are shown in this particular table. You can refer your textbook for this. Okay. Now we shall talk about the angle of contact in the context of intermolecular force. The surface of liquid near the plane of contact with another medium is always a curved surface. Now, angle of contact is defined as the angle between tangent to the surface at the point. For the angle between the tangent to the surface at the point of contact and solid surface inside the liquid is called the angle of contact. Now, see, say for example, you have a water drop, okay, then it will be like this, okay. So, this is the point of contact. You draw a tangent, okay, then this will be the angle of contact, that is theta, which is shown here, okay. Now, this is on the glass plate, we can say this kind of surface is same, or we can say what you call it, the water form. So, water form different angle on different surfaces, okay. In figure A and B, which are shown here, okay, water forms and droplets on lotus leaf is shown, okay, in say figure A, which spread over a clean plastic plate, okay, shown in B, okay. So you can see here that the angles are different. Say this is the what you call it, the lotus leaf, and on the lotus leaf we have this kind of droplet where angle is an obtuse angle. Well, here on the plastic plate, or this is an acute angle, okay. So this way different angles are formed by the liquid which is in contact with the solid, okay.